When we use electricity, we typically think of it in terms of power or energy. Let's first start off by defining watts. This is the unit of power when it comes to electricity, and then we'll talk about the relationship between watts, volts, and amps. So wattage, watts, that's power. Often you'll see it abbreviated, the W for watts, the unit of power, and this is a rate of electrical energy generation or consumption, a rate of power usage or generation. Now, this is an instantaneous measurement. It's the here and the now, what's happening in this immediate moment. And I'm sure you've seen all kinds of appliances that have a power rating on them. It may be the wattage of a microphone, the power of an amplifier. It may be a light bulb, as shown in the picture here. We've got a 15-watt light bulb. So whenever it's on, it is constantly using 15 watts of power. So here's a PV array. We said power or wattage could be used to describe the rate of consumption or the rate of generation. Here's a PV array with a PV 201 lab class that's just finished up a week of hands-on training at our Paonia, Colorado lab facility, and they're standing at one of our roof-mounted PV systems. Consists of 8 separate PV modules, and each one of them is 380 watts. So 380 plus 380 plus 380, on and on we go. 8 of those modules times 380 watts is going to be an array, PV array, with a power of 3,040 watts, 380 times 8. We could also call that 3.04 kilowatts. So a kilowatt is 1,000 watts. We move our decimal place 3 spots to the left from our watt value to come up with 3.04 kilowatts. Now the relationship between watts, volts, and amps is another one that you're going to want to be familiar with, and hopefully eventually it becomes kind of second nature to you. Fundamentally, watts equals volts times amps. So W equals V times A. We can use our circle here for our power equation, much the way you would use an Ohm's law triangle to take advantage of the spatial relationship to give you an easy reference for figuring out what the equation is. Remember, we cover up the W. If we want to figure out watts, we got a V next to an A. That's a V times an A. Watts equals volts times amps. Now we could solve for the other variables here if we wanted to. If we needed to figure out the voltage and we knew the power and the current, well, we cover up voltage and now we have watts over amps. So watts divided by amps, volts equals W divided by A. And then the same relationship is going to essentially be true on the other side for amps. Amps, cover it up. You've got a W over a V. Amps equals watts divided by volts. Now, another way to think about this relationship or to see it represented is looking at what happens when current or voltage changes for the same amount of power. They're going to be inversely proportional. So here I've got 24 volts times 100 amps, 2,400 watts, right? Watts equals volts times amps, or 2.4 kilowatts of power. If I double my voltage, well, now it's going to take half as much current, half as many amps to get me those same number of watts. So 48 volts times 50 amps equals 2,400 watts. Now we've got 5 times the original voltage, 120 volts. We have 1/5 of the amount of current, 20 amps, to get that same 2,400 watts. At 240 volts, 10 times our original voltage value. Now we're at 1/10 of the current, 10 amps to get 2,400 watts. And you can see it goes on. Voltage goes up, current goes down to maintain the same amount of power. So they're inversely proportional. Now, this is a mathematical relationship. The voltage is not usually going to be changing in an electrical circuit, but we may have different circuits that have different voltages. And so understanding this relationship is very important because it has some big impacts on electrical systems. The more current, the bigger the wire I'm going to need. And a wire that carries 5 amps versus a wire that carries 100 amps, is a really big difference in size and a big difference in cost as well. So sometimes we can take advantage of this relationship to engineer systems so that they are cost effective as well. Okay, some key points in regards to power. Electrical power measured in watts. It's an instantaneous value. It equals volts times amps. Remember, 1,000 watts is 1 kilowatt, kW, whereas our watt abbreviation is just the W, and they're inversely proportional. So for the same power in watts, volts goes up, amps goes down by the same level.